Okay, today we are talking about solar water heaters. So there's different types of solar water heaters, specifically the collectors. You have evacuated vacuum tube solar collectors like this. They consist of two concentric tubes of glass with a vacuum in between that emits heat from the sun to heat up the center copper pipe, but limits heat loss back to the environment. And you can see there's a series of several tubes that are lined up, and they attach to a manifold at the top. And this whole assembly usually sits on a frame. And it does have to be at that angle in order to function properly. The inner tube is coated with a thermal absorbent. The evacuated tube collectors are composed of modular tubes connected to a header pipe, as I just said. Different types of evacuated tube collectors. You got heat pipe, all glass tubes with fluid conduit, U-shaped, metal glass. Evacuated tube solar collectors are more expensive than flat plate solar collectors. Another advantage of the evacuated tubes is they are always perpendicular to the sun's rays for most of the day, as opposed to a flat plate collector. So this is obviously advantageous in colder climates or climates that are more cloudy. They might be a better fit, even though they're more expensive. The tubes generally are made of borosilicate or soda lime glass, which is strong, resistant to high temperatures, and has a high transmittance for solar radiation.
Woo!
The internal heat transfer fluid flows to a hot bulb that indirectly heats a copper manifold within the header tank. The transfer fluid can be water and alcohol or glycol. And there's a small graphic on the bottom right-hand corner that shows you the internals. So you can see we have our tubes, our glass tubes, and we have that inner heat pipe with the bulb on top. And that bulb is actually what sticks into that header tank to heat up the water as it goes through the tank.
Wow.
So your heat transfer fluid stays inside that heat pipe. And that's why it's essential that it's mounted on that angle. Now, the other popular solar collector is called a flat plate solar collector. Flat plate solar collectors are much simpler in design and much less expensive than evacuated tube solar collectors. Solar flat plate collectors have the advantage of absorbing the energy from the sun, but also the diffuse solar energy that has been reflected around the collector plate itself, so inside that box basically. Usually, the inside of the collector plate consists of a thin layer insulation on the underside of the unit to help trap the heat inside the collector. Flat plate solar collectors can be either closed loop or open loop, passive or active. A large flat heat absorbing plate, usually a large sheet of copper or aluminum, both are good conductors of heat, are painted black to absorb as much solar radiation as possible to maximize efficiency. There are several parallel copper pipes or tubes called risers running lengthways across the plate, which contain the heat transfer fluid, typically water. Or if you build one of these yourself, obviously you wouldn't necessarily have to use a heat transfer fluid. You could just have the water come out of your holding tank and have a pump that would circulate the water through this flat plate solar collector back into the tank. So the copper pipes are usually attached directly to the absorber plate to ensure maximum surface contact and heat transfer. As the flat plate gets hotter, this heat is conducted through the risers and absorbed by the fluid flowing inside the copper pipes, which is then used by the household. The box or the structure is usually metallic or wooden with a sheet of glazing material, either glass or plastic, on the front to protect the enclosure, the enclosed absorber plate, and create an insulating airspace to kind of help trap that heat inside that structure.
Wow.
So here's yet another example of a flat plate solar collector. This one, you'll note, is made out of copper pipe, and it is a coil of copper pipe. So water comes in, goes through the coil, flows out the other side. Now for this illustration, the copper pipe is the natural copper color. However, if you were to build one of these in real life, you'd want to paint the entire copper coil flat black. And again, the inside of this box needs to be painted flat black to help with the maximum absorption of heat energy. And you want to mount it and orientate it in such a way that you can maximize its sun exposure throughout the day. So different materials available if you want to make your own flat plate solar heat collector, On the right hand side, again, we have 1/2 inch by 50 foot long copper type L coil. At the time of this recording, it's right around $87 at Home Depot. The maximum working pressure is 537 psi with a max flow rate of 6.5 GPM and the max working temperature of 400 degrees Fahrenheit. And this type L copper is rated for potable water supply lines. Just a quick disclaimer, this video is not a paid promotion for any make, model, brand, product, or vendor you see mentioned in this video. Now on the left side, you see 1/2 inch by 250 foot roll of polyethylene tubing, not PEX. This is not cross-linked polyethylene. I want to make that distinction here. And currently it's $80 at Home Depot. So a little bit cheaper and you get a lot more material. However, the maximum working pressure is only 150 psi as opposed to the higher copper rating of 537 psi. The max flow rate is also less at 4.4 GPMs. And I would say more importantly, the max working temperature is only 150 degrees Fahrenheit, whereas the max working temperature of the copper is 400 degrees Fahrenheit.
Wow.
And again, no matter what material you choose, you'll want to paint it flat black before you put it in service. Another option would be 1/2 inch by these 5 foot CPVC sticks that you can buy at Lowe's for $3.82 each. CPVC is different than regular PVC, so we want to make that distinction here. The maximum working pressure is 100 psi, max flow rate is 7 GPM, so right around what the copper GPM is. However, the max working temperature is 180 degrees Fahrenheit, so the CPVC has a higher working temperature than the polyethylene tubing, but again, not as high as the copper coil. And this is also rated for potable water supply lines. If you make one out of CPVC, the primer and glue that you buy to glue all your T's and elbows and pipe together, read the can and make sure it says it's for CPVC pipe. Some primers and glues are just for PVC. Some primers and glues are just for CPVC. Some will do both, so be sure to read the label. If I were to build one of these solar collectors for myself, I would go with the copper type L coil, mainly because of the higher working temperature rating and because the coil is much more rigid. It'll last longer. And if you think about your connections on the ends, you can do, yes, push to connect fittings, but you can also solder or sweat your fittings onto the end of the copper coil, or you can use a flaring tool to flare the ends of the copper coil and use flare fittings, or you can use compression fittings with a compression nut and ferrule. So that would be my preference. Do not use PEX. In my professional opinion, it's not safe because even though it's the cheapest, if you look, PEX piping is highly susceptible to damage by sun exposure. If exposed to constant direct sunlight, the molecular structure of the PEX break down. This causes the piping to become brittle and potentially rupture over time. And you don't take my word for this. Do a Google search, look on the manufacturer's website, and generally they'll have a limited time frame that you can allow PEX to be exposed to direct sunlight. And usually it's a short period of time, like I want to say 30 to 60 days, if I'm remembering correctly. You'll also note the max working pressure on this is 80 psi. Max flow rate is 2.3 GPM. So again, a lot less flow rate than you would do with the copper coil or CPVC pipe. And the max working temperature, 200 degrees Fahrenheit. But again, PEX, whether it's type B, A, C, aluminum, etc. Some PEX has the aluminum lining. Any of them that I've seen on the market are only rated for indoor use only, not outdoor use. So just a very simple overview of how the system works, the major components. You have your solar collector, whether it's the evacuated tube or a flat plate collector. If you have a transfer fluid, there would be a water heater tank like this. You can see there's a coil inside. The transfer fluid would flow through that coil, and then the water inside the tank would absorb that heat energy from that heated transfer fluid in that tank, and the tank itself has very thick insulation. And usually there's a pump that's controlled by a timer and or a thermostat. And sometimes they'll even have an auxiliary electric heating element. So say you're not producing enough hot water to satisfy the thermostat with your solar collector, well, then that electronic heating element will turn on and make up the difference.
Woo!
Please like, share, subscribe, leave me a comment, and thanks for watching.